This is how an amateur has ended up going from ideas to plans to 4 different boats, and been pretty happy with them. Had a couple of people ask me to go into a bit more detail about how I've gone about designing, drawing the plans specifically, and then working from those plans to building these boats. When I saw the comment, my first thought was I just kind of started doing it, but then I thought, well, maybe that's a helpful perspective. Somebody who's just kind of blundered along and built 4 boats that have actually worked out really well. The original boat, Cosmo, a 17-foot day sailor. Our kids, as they were growing up, we did a lot of trips in it, and that was great. And then this boat, years later, my empty nester boat, we wanted something that my wife and I could paddle as sort of a kayak, but also a real sailboat. And then the third boat, my friends Brian and Kim wanted me to build them a sailing rowboat. And I was so happy with that design when it was done. It was kind of like a good grandkid boat. So a variation of that then was Grace, which we've had a great time with the last couple of years. So I'll just kind of talk through going from design to drawings to actual construction. Hope you enjoy the video. So here are the plans for the very first boat, tellingly labeled boat, then named Cosmo, built almost 40 years ago. The sailing kayak, Nomad. My friend's sailing rowboat, which they have since named Boaty Boat. What I called Sailing Rowboat 2, SRB 2, now called Grace. And let me just start by how this project came about, and then talk about some of the key decisions, what kind of boats that my approach will and wouldn't work well for. And then we'll do a little bit of drawing and a little bit of how to turn that into the ribs or formers, and which then go on the strong back. So what happened was some friends of mine were over for dinner. Deb and I were talking. I think I said, you know, it'd be kind of fun. I've always loved sailing since I was really young, but we had no money then. I was trying to put us both through school and construction. But I said, you know, it'd be fun to just build my own sailboat. And the other 3 of them all looked at me skeptically. The skepticism got a little stronger. So I remember dragging out my 25-foot tape measure, stringing it down the living room floor. And at that point, the bug had bit. And the next day, I remember sitting on the front porch, it was weekend, and starting to draw. So this is a little fragile here. Top view. And this is the side view. And I knew I wanted something about the size of the boats I grew up around. My uncle and then my grandfather and then my dad had Highlander 308. That's about a 20-foot boat. So I was initially thinking of something that size, but you can see here, I realized I've got this little 1-car garage to build in, and 20 feet would be too long. So that determined the length to actually be 17 feet, which turned out to be the size of a Thistle, designed by the same guy who designed the Highlander. I ended up using Thistle rig, mast, boom, centerboard, rudder, and sails. So when I began drawing this, I didn't think about it a whole lot carefully, but I was assuming that I would build what is called a hard-chine boat. Chine is the corner between the bottom of a boat and the side of the boat, and the alternative is a soft chine boat where it's a gradual curve. I assumed that I was going to be building a hard-chine boat because I think I realized I don't have a lot of technology here. I could build this out of plywood. You can have a sheet for the bottom, a sheet for the side. Stretching those curves out, getting them right seemed doable to me with my low technology. So those were all sort of things I assumed without thinking it through very much. So everything I'm going to share with you is assuming that a hard-chine boat using plywood will suffice for your design. Alternatives like soft chine take quite a bit more drawing and lofting, and if you're building it out of planks, there's a very long and awesome history about how to do planked boats. If you're going to go fiberglass, you need a whole lot more technology, molds. An alternative then would be steel origami, like the awesome SV Seeker. There's my artifact from SV Seeker. Fantastic project. Doug Jackson is such an amazing guy. I was really watching and enjoying his videos and his eagerness to help other people achieve their projects, including other boat builders and video makers, that got me started thinking, if I'm going to build Grace, I'll go ahead and try to learn to do videos as well. So thanks, Doug. And we cannot wait to see SB Seeker in the water sometime soon. I looked when I was going to build my sailing kayak at stitch and glue. Not far off from the boats that I build, but there again, they tend to use plywood, typically hard-chine. Stitch and glue, you've got to have the exact shape of the side and bottom pieces known in advance. With this technique, drawing in very small scale, this is 1 inch equals 1 foot for all 4 of these boats, you don't have to be that precise. Lay out the key curves, but those curves are greatly reduced from, say, a soft chine boat, right? You've got what's called the shear, viewed from the side and viewed from the top. You've got the chine, where the side meets the bottom, again viewed from the side and viewed from the top. We've got what I've been calling the keelson. It's not really a keel on any of these 4 boats, so I've heard that term used, so I've just called it the keelson. Running down the center line, basically 3 curves. And if you get those reasonably the way you want them, we'll talk about how to do that. You can pull measurements that in turn, at slices across the boat, will give you what you need to create in real size the ribs or formers, and then to put those onto a strong back and start building. The idea is, if you know you're going to build a hard-chine boat with plywood, then a couple of things follow from that. Once the side and bottom pieces of the plywood are securely joined with sufficient strength, then you don't need frames, as they're called in traditional boat building, often every foot or so, or even more for a traditional planked soft chine boat. That finished structure with plywood is going to be so strong that the frames, or ribs as I've tended to call them, don't need to be that frequent, just sufficient to get the shape reliably built in full scale with the stringers longitudinally along the boat in order to get the plywood on it, and secondarily key points where you need to hang internal structures. So in the case of Cosmo, I have a rib here that sits underneath the mast, and I have rib here that has a main thwart that helps to hold the centerboard trunk, and then some interior benches. You can see that same principle at work in Grace. I had 1 removable former in the middle, and then the rest were permanent ribs, R4, R2, and R1, and all of that was sufficient to get the curves right as the stringers were going on, sufficient for, adds a little bit of strength at key points. You know, obviously this helps with the mast step. A lot of forces down there on this stainless mast. This helped bring the main thwart together with the rest of the hull, with the daggerboard trunk in there, so a lot of stress there. And to begin the side benches, R4 help to hang the other end of the side benches on. So that same approach is carried through. In the case of Nomad, the sailing kayak, there were 2 temporary formers in here, and then a permanent rib up here, here with the daggerboard trunk and the deck, and R5 for the aft deck termination point. The other advantage of this technique is if you're working off these small scale drawings, try to see how the curves actually lay out. And in all 3 of these other boat cases, I really can't remember if I had to do this here, tiny little adjustments were needed. And if you're doing stitch and glue, if you're doing a molded fiberglass boat, or if you're doing a planked boat, it's a little harder to make those adjustments along the way. Here you're able to shave a little bit more and change the contact point, say, of a chine stringer coming past one of the ribs to get the curves fair. As they say, there's a continuous attractive curve. You can move the ribs up or down relative to the strong back, working from very small scale drawings where pencil width can be nearly 1/4 of an inch, and the 1/4 of an inch is visible on these boats. This technique allows you to make some adjustments on the fly. As the plywood goes on, you can, let's get the fore and aft view here of Cosmo. From the bow, from the stern, plywood goes on, you can put the bottom pieces on and let them hang long, at least up until this angle gets too flat, as it did on the sailing kayak and on the other 2 boats. Trimmed it to the frame, let the side hang long, and trim it to the frame as well. So again, you're saving a lot of time, a lot of precision fitting, unlike a planked boat. Just sort of realized I think I could do that, and worked out very well. So hard-chine, using plywood, not having to be super precise in advance. So I've designed these things. Each one of the 4 has only been built once. If that fits your project, then maybe some of what I've got to share here will be helpful to you. Okay, so having decided the basic approach to building, design phase, the other key parameters: length, width, and then interior details and rig. So that's all kind of driven by what kind of boat you want. With my first boat, Cosmo, I knew I had a family on the way. Eventually I had 3 awesome kids, and I had visions of camping out of it, day sailing on lakes around here in the Great Lakes, which we ended up doing. And for the sailing rowboats, 14 feet seemed like small enough to be rowable. Anything bigger than that gets kind of sluggish if you're trying to paddle or row it. And yet enough to teach the grandkids to sail and take some people out, and I could solo sail it much more easily than I could Cosmo. So there's basic parameters based on features you want, which drives length. The next question then is width. If having settled on the length, with width there's a trade-off between stability. The wider it is, the more stable. So I wanted this to be a family boat. I made it slightly wider than the Thistle, 6'6" beam, and indeed it's turned out to be pretty forgiving. We've had it in some pretty serious weather over the years. Compare this then to Nomad sailing kayak. The wider it is, this more sluggish or slower through the water, less efficient to move through the water. And I wanted the sailing kayak to be paddleable. So we got a very thin beam for the length, 13-foot length, and only 30-inch beam. So this is a super tippy boat, but I was content with that trade-off because I wanted it paddleable and it'll glide through the water. You get your length, you get your width, and then it's on to some other key decisions that will drive the ultimate design. All right, here's the plans for Grace. Having decided you're building a hard-chine boat out of plywood, make it a certain length, a certain width. Before getting down to drawing these 3 curves, you're into then a couple of other key questions. I'm assuming we're building a sailboat. That's what I love. So you're starting to think about the type of rig. Cosmo was what's called a sloop rig with a big mainsail that was held up by traditional stays, 2 shrouds and a forestay. So the mainsail and a jib. the sailing kayak. I knew I wanted a simple stainless mast with the rig easily removable. In the case of Grace, I knew I wanted a stainless mast. I wanted it really simple so that whole rig could easily be pulled off the boat. It could be used as a rowboat or motorboat. So those are key decisions. From there, you're starting to think about structural forces. You've got a combination of sideways forces and forward forces on the sail in a sailboat. And if you don't have some kind of fin, those sideways forces, you just slide through the water sideways. Whether that's a centerboard, like on Cosmo, or dagger boards, like on the other 3 boats I've built, or keels on great big boats, which also provide ballast to keep them upright. These little boats don't have any ballast. You are the ballast as you sit in it. You need the force to be relatively balanced. So if the sail were all the way forward and the fin were back, the boat would constantly be wanting to turn downwind. That would be called a lee helm. What you want with the balance of force is you want a slight weather helm as a safety issue. It just feels more comfortable. If you let go of the tiller, it'll turn into the wind. They call that a weather helm. So you're thinking about where the sail's going to sit, the center of effort from the sail especially, versus where the fin, in this case a dagger board for Grace, will sit. And you can do ratios for common boats. In the case of Cosmo, I knew it was much like a thistle. In fact, I was going to use a thistle rig, so I actually did that. I measured where is the center board fore and aft relative to the mast. The design decisions, the feature decisions drive the interior structure, and you're thinking about all those things. Ultimately putting either temporary formers like this that comes out of the boat after it's done, or permanent ribs like these, because they're associated with key structures you need. All right, so all that's run up to actually drawing. So what I think I'm going to do is recreate, at least to some extent, Grace. So the very first thing I did, you're not going to get a 17-foot boat or even a 14 or 13-foot boat at that scale onto one piece of paper. So I decided I'll Scotch tape them together. So let's go ahead and do that. Decided I'd need a side view and a top view, and I'll show you why. That has been the most important drawing. This is going to be the top view and side view. And I'm using pen for a very few items. The main reference lines and things that, as I repeatedly erase over, which you will need a good eraser, that stuff we don't want to change. So let's start with the side view. We know that Grace is 14 feet long, and as you can see here, I've got a reference line because we're going to need height measurements from the side view from an arbitrarily chosen reference line, and that's what I've recorded here. Keelson, chine, and shear at each of these slice points. So why this reference line? Well, when the boat's upside down on the strong back, you're going to position these ribs precisely in their fore and aft spot, and then really critically in their height spot. So as you'll see in the videos of building Grace, positioned a chalk line string both above and below so you can get it plumb. And we're going to measure down from that string on each of those ribs. So I'm going to go ahead and make that 14 feet long reference line. This magical deal is going to tell you how many inches in the drawing scale a fraction of an inch would actually be. So there's 3 inches, which is 1/4 of an inch, yeah, and it gets harder from there. So this is super handy. Make sure we leave enough room for notes and get a longer straight edge. Get some right angles up. So what do we need for the top view? Well, we need the center line and the length for that as well. Center of the page. All right, so we've got the center line on the top view and squared off there. We've got the reference line and then the ends there from the side view. We've got 4.5 decisions already made about where the ribs or formers are going to be. So we've got a distance back for R1, and similarly on the top view. 2.5 feet, 2'6". And we've got an R2 at 5'6". So 5'6". R2. We've got a former, we call that F3, and it sits at 7'10½". This is where that scale ruler becomes super helpful. 7'10½". And finally, we've got R4, which sits at 10'6" back from the bow. R4. And the last piece of the boat then is the transom. I decided, in the case of Grace, to make the transom angled a little bit, sort of a dory style. It's also sort of the idea of you can take this boat into heavy weather. Let me draw in the cross points, and then we'll start talking about battens and curves. We could start with the top view curve, and the next decision would be how wide is the transom. This decision is a bit aesthetic. You can look at similar sized boats and see how it looks. If you look at Grace here, you know, there's the 4'6" beam right amidships, and then tapering back to that transom. So in the case of Grace, I chose a transom at the sheer, the total width that was 3 feet 2.5 inches, using a batten, which is a piece of wood or maybe even better, plastic. It needs to be pretty even grained so that it will bend in a continuous fashion. And start thinking, that looks about proportionally right. You can push the curve a little farther forward, a little farther back. You get your batten and you get some little nails. You start looking at the curves. Something that looks, we know we want the line. As you slide the pencil around the batten, kind of to come through those contact points so we can pin it. One of the things you got to watch out for trying to get a curve, these small scales that will ultimately look halfway decent, is you want to continue the curve on past the ends a little bit. You can see how that flattens out there. So you don't want that in the boat. You might want to push this curve out a little bit more toward forward. And continue that curve slightly past the transom. Now look, it's actually pushed that out. So I have to put it back in. Let's go ahead and draw, connecting those points. We now have to decide where the other curve, which is the chine, is. And at that point, you're starting to have to envision, what does this thing look like from the front, from the stern? How far in? How tall will the boat be overall? So you can see on Grace here, there's sort of a continuous, fair amount of flare. That's a bit of an aesthetic thing. There's a slight safety factor. You can imagine if these sides kind of came to perpendicular and the boat was getting heeled way over, a little bit of flare will help keep water out of the boat, help keep you upright when you're right on the edge, but it's mostly aesthetic. The other big decision with a hard-chine boat, where you've got basically a bottom piece and a side piece, is what happens toward the bow when they come together. And in the case of Nomad, and in the case of Grace even more, I decided I wanted to make that bottom piece twist quite a bit, which worked out. And so bring the chine transitioning up So all of a sudden, this is almost perpendicular across the stem. This piece here is called the stem. Cosmo, it was very different. I kept the chine down here, so the stem came down and then kind of turned into the bottom, and that allowed the bottom to remain quite a bit less twisted. So you got some decisions there. You got some decisions about the overall height of the side of the boat. You can look at comparable boats. Too high looks kind of clunky and it's hard to climb in if you fell overboard. Too low, of course, means you have not enough freeboard. If waves are coming from the side, freeboard is the amount of side of the boat that sticks up out of the water. The decision on the overall height, the way the chine's going to come together, the angle of the sides as it goes along, and that's going to tell you then where this chine line needs to land as you draw these curves out. So I'll put onto our drawings where those same decisions landed me with Grace and show you how that works out. The chine intersection point as it's going across the stem was 2.5 inches back, and that's where this line goes to 0. We can draw that in now. All right, so here's the crucial thing then. We had basic width or beam, basic length, some idea of the curve, the size of the transom. We can now use the scale drawing to take horizontal measurements, which together with the vertical measurements will allow us to actually draw out R1, R2, F3, R4. What do I mean? Well, here we have a distance from the center line of 11 3/4 inches. Say at the chine, 11 3/4 of an inch. At the shear, we've got 1 foot 3 1/4. We've got 1 foot. When I say 1 foot 3 1/4. All right, and we can go on down there and draw all of these measurements off of the plans. Going down to the side view then, basically you can see that you've got a fair amount of rocker here, something like 3 inches. So that's turned out to do really well. I've been in some pretty steep waves in Lake Erie, and so I'll kind of replicate that same curve. I've generally felt like a continual-ish curve along the keelson and then joining to another sort of a curve across the stem. Seems to be what my eye ends up liking after the fact. I'll just reflect in some of those decisions I already made for Grace, basically the side being like 13, 14 inches down to the chine and then a fair amount of V-angle from there. Trying to make these curves look flowing, natural. And the last piece then, drawing the transom and draw the shape of the stem. This thing won't end up exactly like Grace. Here I can tell that I've diverged from what I did in Grace. You can see that I tried to bring the water line forward, which is good for efficiency, so I probably would end up adjusting this line. We want the intersection of the chine to be 2.5 inches back from there. So you're going to work out some kind of a curve that you like. The longer the water line is for the width, the more efficient the hull will be. So this has ended up with being a slightly different shape than Grace. You can see all the holes, all the erasure marks in my other drawings. I'll just do one iteration of these sorts of many adjustments that actually occur the first time you're designing out a boat. All right, so what happens next? We're going to use the drawings to take 3 measurements in the vertical plane, 1 to the keelson, 1 to the chine, and 1 to the shear. So to the keelson, we've got at R1 7 inches. And I'm trying to be accurate to the 1/8 of an inch if I can. And to the chine, we've got 1 foot 2 1/4. And finally to the shear, 2 feet, 2 3/4. And we'll do that all the way down here. So with all of these vertical and horizontal measurements, we can move on to drawing a 4 1/2 view. And you can imagine if you're actually wanting to make the ribs, make the formers, it would be a full-scale version of this. Let's do R1 first. The keelson's up at 7 inches. It would probably make more sense to do a different scale, but I'm going to keep it simple and keep with my 1 inch equals 1 foot for this purpose. So we've got the keelson at R1. We've got up to the chine, which is going to be somewhere out here. The chine is out 11 3/4, and it is up 1 foot 2 1/4. So that's the chine for R1. And then you locate the shear, which is up 2 foot 2 3/4 and out, see these measurements here, out 1 foot 3 1/4. So we're coming out 1 foot 3 1/4 and up 2 foot 2 3/4. And now you've got the shape of R1. And again, if you were doing this full scale, you'd actually be laying this out. A paper pattern is what I typically did, and then use that to position onto a sheet of plywood. That actually passes the straight face test. It's going to be straight across. On Grace, I made my ribs 2 1/4 inches thick, so you could actually also draw that out if you wanted. Let me just position R2 the same way, and then F3, and then I'll show you what we can do to validate these lines from the forward view. All right, there's R2 against R1. We'll do F3, and we get to see if the way we'd like this whole thing to lay out actually works from a 4 1/2 perspective. That's the idea. You can see how we can use the information we've got on the side view and the top view to construct full-size these ribs. Now let's do where the chine intersect point is, which is up 1 9 1/2. Be the chine, and you should be able to take a batten and draw a nice clean curve. This batten's a little too thick for this small scale. Similarly, we can look at the overall height at the shear at the bow, and that's at 2 feet 6. 2 feet 6. Should be able to draw a curve along the batten along that shear line. So this is the process I've been through on each of these boats, trying to imagine it, validate it from the 4 1/2 view. Sometimes you go back and you say, like in this case, is that chine line quite correct? Does it really want to be heading back uphill as it goes across F3? Yeah, maybe. Maybe that's all right. And then you could do a stern view as well and see if these lines form smooth looking fair curves. And if not, move certain things, which may involve move certain other things, erase and redraw, adjust those measurements. But hopefully you can see that once you're committed to these curves and these measurements, because it's a hard chine boat with just a side and a bottom, you can use those measurements to give you everything you need, not only to draw out full scale each of these ribs or formers, but then to position them over the reference line on the strong back in their proper 4 1/2 places, and begin the process of running the chine and shear stringers and the keelson and making the boat. So this is how an amateur has ended up going from ideas to plans to 4 different boats, and been pretty happy with them. So thanks for watching. If you got questions or comments, I'd love to hear them.